This presentation details my software engineering project in third year. The project was done in collaboration with Integral Ad Sciences, an advertising company. The goal was to create a system that could analyze videos and identify important objects in these videos. This is useful for the company because they could serve more relevant ads based on the objects in the video. 2 employees at the company were our mentors who guided the process. They provided a clear project outline and research materials. The work combined technical challenges with practical applications. It was an opportunity to apply classroom knowledge to real-world problems, improving both our technical and teamwork skills. The team consisted of both third-year and second-year students, and as a third year at the time, I had a more managerial role, while the second years were encouraged to do most of the programming. The aim was to build a system that detects objects in videos. It needed to work with live and recorded videos while running efficiently on standard hardware. We had to use our own laptops as we were unable to acquire external computational resources. Reducing the number of frames analyzed was essential to save time and resources on the back end, and we were given multiple example approaches to help guide us in this task. The system also needed to support different video sources like live streams and YouTube links to make it robust. As an example, one of the use cases we were given for this project was analyzing video streams from CCTV cameras, which meant that streaming input was an essential requirement. Therefore, our focus was on balancing performance and usability. We were also encouraged to reduce duplicate detection of the same object across multiple frames, such as what occurs when a detected object moves within the course of the video. We used an agile workflow as per our module requirements, with weekly meetings to track progress. We split tasks into front-end, back-end, infrastructure, and database teams to ensure we could remain focused on our task. I was on the infrastructure team, which handled the container setup and orchestration. We used pair programming to make sure all the parts worked smoothly together, and it also let us help the second years with their technical programs during their coding. Our mentors helped us select programming libraries to manipulate the video frames, and we used containerization and continuous integration to keep the development process efficient. We used automated testing to catch the errors early as soon as a pull request was created. We used the YOLO V8 model to detect objects, and the OpenCV library was used to extract video frames. This approach yielded a pipeline structure where, after the video was uploaded from the front end to the back end, it was then sent to a frame extractor which found the most important frames to extract and sent them to the next stage, where the frame would be sent to the YOLO V8 model, which would then return the probability of the frame containing any objects, and if it did contain any objects, their positions in the image. As these steps were almost independent, we were able to have different people working on these stages concurrently, which helped us work faster. We also relied on heuristics to track objects moving across frames in our frame selection step to reduce duplicate detections of the same object. The system successfully detected over 100 object types. It could process live streams and YouTube videos, and it ran efficiently on our laptops, making it practical and accessible. We analyzed frames to develop a method that skipped similar frames, which improved performance and saved resources, but these optimizations did not affect the accuracy of our model. The system met all its objectives and demonstrated flexibility, reliability, and efficiency. We also implemented a functioning user authentication system, which persisted to a database on the backend so that each individual user could save their own uploaded video results on the backend. The system was able to analyze most videos in under a minute when running both the front end and back end on the same laptop, which proved its ability to scale. The project achieved all its goals. The agile approach kept progress organized and let us adapt easily. Our mentors provided critical guidance, and us mentoring the second years reinforced our understanding and helped develop a shared knowledge base. Hardware limitations were of course a challenge, but we developed creative solutions and we adjusted our aims to help keep development on track. The project delivered a functional and efficient system while providing valuable hands-on learning experience. It was a key step in applying academic knowledge to real-world applications.